Hello guys, you're welcome to my YouTube channel Mathematics Made Easy. So in today's video we'll be solving this question. It's gotten from the MIT 2025 Calculus B. Okay, and here's the question. Integral from 0 to infinity of the x over x plus 1 plus the floor function of 2 root x, then everything raised to the power of 2 equal I. So we have to find the closed form of this beautiful integral. Okay guys, so before we start solving this problem, so don't forget to subscribe to my channel, like my videos, comment, and then share. So God bless you. Okay, now let's start solving this beautiful problem. So the first thing is to understand the nature of this function f of x, which is equal to 1 over x plus 1 plus the floor function of 2 root x, then everything over 2. So that's the first thing to do. We have to understand the nature of this function. And then you can see we have the floor function here, which is the floor function of 2 root x. Now this floor function here, it introduces the piecewise behavior. So now let's analyze this. So analyzing this, we can say that let n be an element or be a member of the set of natural numbers. So if n is a member of set of natural numbers, then we can say that the floor function of 2 root x equals n if and only if and only if this below inequality is satisfied. If and only if n is less than or equal to 2 square root of x and is less than n plus 1. So if n is less than or equal to 2 square root of x and then is also less than n plus 1, then we are going to say that the floor function of 2 root x equals n. Now the next thing we are going to do here is to find x. So you can divide through by 2. Then if you do that, we're going to have n over 2 is less than or equal to square root of x is less than n plus 1. So the next thing you're going to do is to square everything. So squaring, we're going to have n over 2 raised to the power of 2 is less than or equal to x is less than, sorry, this over 2 here. So n plus 1 over 2, everything raised to the power of 2. So then we are going to have n raised to the power of 2 over 4 is less than or equal to x is less than n plus 1 raised to the power of 2 then over 4. Okay, so on the interval, that is x is on the interval n squared over 4 comma n plus 1 raised to the power of 2 over 4. So then the integral, this original integral will be equal to summation of n from 0 to infinity, then of integral, the limit will change from n squared over 4 to n plus 1 raised to the power of 2 then over 4. Then we have the x over x plus 1 plus n everything raised to the power of 2. Since we've substituted the floor function of 2 root x to be n, so we have to put n here instead of the floor function of 2 root x. Okay, so the question is now becoming easier since we've transformed this to an easy integral. So what you have to do next is to integrate this integral correctly. Now, for us to integrate this integral correctly, you can make substitution. Okay, then if you make substitution, we're gonna have something like this. So we're gonna have I, let me write it out. I equals summation of n from 0 to infinity, then an integral n raised to the power of 2 over 4 into bracket n plus 1 raised to the power of 2 over 4, then of 1 over x plus 1 plus n raised to the power of 2. So we can make a substitution here. So make it a substitution. So we can say that let x plus 1 plus n be equal to u. Let x plus 1 plus n be equal to u. Then if you do that, so you differentiate both sides. So we have the x equal the u. And then take note, since we are making substitution here, the limit is going to change. So for lower limit, when x is n squared over 4, so we're going to have n squared over 4 plus 1 plus n, which is the same thing as n squared plus 4n plus 1, everything plus 4n plus 4, then everything over 4. So which is equal to n plus 2 raised to the power of 2 over 4. So that is the lower limit. Then the upper limit is going to change also. So you substitute x to be n plus 1 raised to the power of 2 over 4. So we're going to have n plus 1 raised to the power of 2 then over 4 plus 1 plus n. So which is equal to n plus 1 raised to the power of 2 plus 4n plus 4 then everything over 4. So this will be equal to n plus 1 if you factorize. So we're going to have n plus 1 multiplied by n plus 5, then everything over 4. That's the upper limit. Then the lower limit we have this, the upper limit we have this. Okay, so let's move on. So moving on, we are going to have I equal summation of n from 0 to infinity, then of integral. So instead of writing n squared over 4, so we'll be writing n plus 2 raised to the power of 2 over 4. Then for the upper limit, instead of writing n plus 1 raised to the power of 2 over 4, so we're going to have n plus 1 multiplied by n plus 5, then everything over 4. Then instead of writing x plus 1 plus n, so we'll have u, so that'll be 1 over u raised to the power of 2 the u. So this is beautiful. So integrating this 1 over u squared is so easy. So you're just going to have u raised to the power of minus 2 plus 1 over minus 2 plus 1, which is minus 1 over u. So that's the integral of 1 over u squared. So we're going to have I equals summation of n from 0 to infinity, then over negative 1 over u. You can bring the negative sign out, okay? Because if you integrate 1 over u squared, you get negative 1 over u. So we can bring it outside like this. So we're going to have 1 over u inside the bracket. Then you apply the limit, n plus 2 raised to the power of 2 over 4. Then we have n plus 1 into bracket n plus 5, then over 4 here also. Yeah, that is nice. So we can now substitute the values of u here, that is the limit. Now substituting that, we're going to have I equals negative summation of n from 0 to infinity. Then of now if you substitute u to be n plus 1 into bracket n plus 5 over 4, 1 over n plus 1 into bracket n plus 5 over 4. So this is as 4 over n plus 1 multiplied by n plus 5. Then minus, then if we do the same thing here also, so this will be 4 over n plus 2, then raised to the power of 2. So the next thing we can do here, you can see 4 is coming throughout inside the bracket, so I can factorize. I can factor out 4. So if I factor out 4, so I'm going to have negative 4, then multiply by the sum of n from 0 to infinity into bracket 1 over n plus 1 multiply by n plus 5, then minus 1 over n plus 2, then raised to the power of 2. So what we're going to do next is to split this into partial fraction. So we split 1 over n plus 1 into bracket n plus 5 into partial fraction. So we're going to have in a negative 4 multiplied by the sum of n from 0 to infinity, then into bracket we're going to have 1 over 4 into bracket n plus 1, then a minus 1 over 4 into bracket n plus 5, then a minus 1 over n plus 2 raised to the power of 2, which is this. Wow, that is beautiful. That is beautiful. Okay, so you can take the sum. So taking the sum now, we're going to have minus 4 summation of n from 0 to infinity, then into bracket 1 over 4, then over n plus 1, minus 1 over 4 into bracket n plus 5. Okay, then minus this minus will give us plus here, so plus 4 sum of n from 0 to infinity, then of 1 over n plus 2 raised to the power of 2. Okay, so you can factor out this 1 over 4. So if you factor out 1 over 4, so 4 is going to cancel out 4. So what we are going to have now will be negative summation of n from 0 to infinity into bracket 1 over n plus 1, then a minus 1 over n plus 5, then a plus 4 multiplied by the sum of n from 0 to infinity of 1 over n plus 2 raised to the power of 2. Now, beautiful. So we can call this summation, right? You can see these are telescopic series, okay? So we can call this S1, then I can call this also S2. Now, the first thing, let's solve for S1. So let's solve for S1. What will be the value of S1? Okay, so we have S1 equal negative summation of n from 0 to infinity, then of 1 over n plus 1 minus 1 over n plus 5. Yeah, guys, let's move. So by substituting the values of n from 0, starting from 0 to infinity, so this is what we're going to have. We're going to have S1 equal negative, then into bracket to substitute n to be 0. So we're going to have 1 over 1. Sorry, let me clean that. It's looking like negative. Okay, let's move on. So we're going to have 1 over 1 if you substitute n to be 0, 1 over 1, then a minus 1 over 5. Okay, then if you substitute n to be 1, we're going to have plus 1 over 2, then a minus 1 over 6. Also, if you substitute n to be 2, so we're going to have plus 1 over 3, then a minus 1 over 7. Then if you substitute n to be 3, we're going to have plus 1 over 4, then a minus 1 over 8. Then if you substitute n to be 4, so we're going to have 1 over 4 plus 1 over, minus 1 over 9. Minus 1 over 9. Okay? Minus 1 over 9. All right, then if you substitute n to be 4, sorry, this is 1 over 5. So if you substitute n to be 5, so we're going to have 1 over 6, 1 over 6 minus 1 over 11, so and so on and so forth. So that's what we're going to have. Okay, now this way you have to check here, so you have to be very careful. Now you can see that minus 1 over 5 we cancel out 1 over 5 later on, minus 1 over 6 we cancel out 1 over 6. Also, yeah, 1 over 7 we also cancel out 1 over 7 later on. You know, if I substitute n to be 6 right here, so I'm going to have 1 over 7, so it's going to cancel out 1 over 7. Then a minus 1 over 11 we cancel out 1 over 9 we cancel out. Also 1 over 8 we cancel out if I start substituting the values of n. So what remains here is 1 over 2, we have 1 over 3, and we have 1 over 4. That's the numbers remained in the series. So we're going to have minus, then into bracket 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. So that's what we're going to have. Okay, guys, so this is very beautiful. So we have S1 equals negative. Then I check the LCM here, which is 12. Then second the LCM, which is 12. Then 12 divided by 12, we have 1. Multiplied by 12, we have 12. Then 2 divided by 12, we have 6. Multiplied by 1, we have 6. Plus 2 divided by 12, we have 4. Multiplied by 1, we have 3. Then 4 divided by 12, we have 3. 3 multiplied by 1. Sorry, this is 4. And then this is 3. Okay? So we're going to have S1 equal negative, then 12 plus 6 plus 4 plus 3. So that's going to give us 12 plus 6 plus 4 plus 3. That should give us 20. Is that 25? Yeah, that should give us 25 because 6 plus 4, that's 10. 10 plus 12, that's 22 plus 3. So we have 25 over 12. We have 25 over 12. So that is x1. So x1 is negative. We have negative 25 over 12. That's s1. Okay, guys, so let's move to s2. So we know that s2 is 4 multiplied by sum of n from 0 to infinity of 1 over n plus 1 raised to the power of 2. N plus 2 raised to the power of 2. So we have s2 equals 4 multiplied by sum of n from 0 to infinity of 1 over n plus 2 raised to the power of 2. So yeah, I don't want to stress myself too much in some of this series. So I have a generalized formula for that, for this kind of series in trigamma function. Okay, and here's the generalized formula for that. We have sum of n from 0 to infinity, then over 1 over n plus x, then the rest to the power of 2. So this is the same thing as the trigamma of what? Of x. Okay, now right here x is 2. Okay, so you can just substitute x to be 2. So I'm going to have s2 equal 4 multiplied by the trigamma of 2. Then we know that the trigamma of 2 is a constant, which is pi squared over 6 minus 1. So we're going to have 4 into brackets pi squared over 6 minus 1. Okay, so that's the trigamma of 2. Trigamma of 2, we give you pi squared over 6 minus 1. Okay, guys, so since we have S1 and we have S2, then we're going to have I equal S1 plus S2. Okay, that's what we're going to have next. So if I equal S1 plus S2, so we have S1, which is negative 25 over 12. We have S2, which is 4 into bracket pi square over 6 minus 1. So, guys, we're going to have minus 25 over 12 plus 4 into bracket pi squared over 6 minus 1. That is I. That is I. Okay, guys, so let's move on. Okay, you can also open the brackets right here. So we do that, we're going to have minus 25 over 12 plus, pi squared over 6, we can use zeta of 2 for that. Okay, so that will be 4 multiplied by the zeta of 2, then minus 4. And then you don't want to use the zeta of 2, we can simplify this. Okay, so let's just simplify this without using the zeta of 2. Okay, so let's simplify this. So 2 in 4, there is 2, 2 in 6, there is 3. So we're going to have 2 pi squared over 3, then a minus 4. So what we're going to do next is to collect like terms. So collecting the like terms, so we're going to have I equals 2 pi squared over 3, then a minus 25 over 12 minus 4. So we're going to have I equals 2 pi squared over 3, then a minus, the LCM will be 12. Okay, so plus into brackets 12, then 12 in 12, that is 1, multiplied by minus 25, we have minus 25, then minus 12 and 1, that is 12, multiplied by 4, we have minus 48. Then a minus 25 minus 48. Minus 25 minus 48 will give us, that should give us minus 73. Okay, so we're going to have I equal to pi squared over 3, then minus 73, then over 12. So that's the answer to the question. We can also say that I equals 1 over 3, then into bracket 2 pi squared, then a minus 1 of 73 over 4. So that's the answer to that beautiful integral. So guys, once again, don't forget to subscribe to my channel. Don't forget to like my videos, share. Thank you for watching. See you next time.